Changes of financial prices are often expressed in terms of returns. To compute a return in a given period, we need the initial and the final prices. Depending on the period considered, we can define daily, weekly, monthly, or yearly returns. In this chapter, we will assume that the horizon for the calculation of the return is a day. You're probably already acquainted with simple daily returns. In fact, this is the preferred form of informing about changes in stock prices in the media. When we say that a stock index has gone up 2%, we mean that if the closing value of the index yesterday was 100 and today it's 102, we have a 2% return. Let's see how these simple returns are defined from the time series of asset prices. So assume that we have the asset prices at time t0, t1, tn-1, tn. The prices are S0, S1, Sn-1, Sn, dot, dot, dot in the middle, of course. The returns will be R0, R1, dot, 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 up to Rn-1. We can only calculate up to n-1 from the time series up to n. The definition is the following. R sub n is equal to the price at time tn plus 1 minus the price at tn over the price at tn. And this would be valid for n equals 0, 1, 2, up to n-1. Let's now assume that we have a portfolio that invests in d different assets. So we'll have prices for the dth asset and the corresponding returns. And we have the time series of portfolio values. P0, P1, P2, up to Pn, and the value of the portfolio at each time step is calculated using the number of shares that we have invested in asset D times the price of asset D at time Tn. And this we do for times n equals 0, 1, 2, up to capital N. In terms of this series of prices, the series of returns of the portfolio is defined as follows. The return of the portfolio at time Tn is Pn plus 1 minus Pn over Pn. Using the definition of the portfolio value at time Tn and at time Tn plus 1, we can define this expression for the returns in terms of the prices of the component assets. We're going to multiply this expression by S and D and divide by S and D so that its value doesn't change. Here, we recognize the weight of the dth asset at time Tn, and here we recognize the return of the dth asset. So the portfolio returns can be expressed as a convex combination of the returns of the component assets. Let's look at the series of returns for the components of the portfolio that we have created. So this is the time series of prices for IBM. We can see that the series is highly non-stationary. If we take, for instance, the average in this period, the series is increasing. In this period, however, the average is decreasing. If we compute the returns, and this is the time series of returns, we see that the time series is not quite stationary, but it's a bit more stationary than this other one. In particular, the average is more or less constant, slightly above 0. You can see that the fluctuations, the variance of the time series, seem to be larger in certain periods, for instance here and here there seems to be a lull in volatility. This means that the series of returns is not stationary either. However, it is more stationary than the series of prices, and we can model it reasonably well by a stationary process. The time series of prices and returns for Google exhibits the same type of features. We also have a high volatility period around the crisis here. This is, remember, 2007, so it should be 2008. And Siemens has a similar behavior. From this time series, we can build the time series of portfolio values and also of portfolio returns. Again, the features, at least qualitatively, are similar to the time series of prices and returns for the underlying assets. And here is the code to compute these returns. The program is called demo code simple returns. The first operation we'll do is load the data from the data file that you have created with the closing prices of IBM, Google and Siemens. We'll take a look at a series of only 7 prices just to illustrate the properties of the simple returns. Since in this course the convention is that each row corresponds to the time series of the prices of a single asset and that time increases with the index of the columns, we'll have to take the transpose of S. And this is the result that we get. The first row are the prices of IBM, the second row are the prices of Google, and the third row are the prices of Siemens. So we have D assets, D equal 3, and a time series of length 7. We can compute the asset returns using this formula. The only complicated thing in this formula is this operation. Basically what we're doing is for all of the assets, we're taking the prices between the second and the last day and dividing them element by element by the prices between the first and the day before last. Then from that ratio we subtract 1 and multiply by 100 to get a percentage. These are the returns. Again, the first row corresponds to IBM, the second row to Google, and the third to Siemens. Let's now build a time series of portfolio values. The portfolio will have 5 shares of IBM, 2 shares of Google, and 2 shares of Siemens. The series of portfolio values is computed using this formula, which is just the number of assets times the series of prices. This is the time series of values for the portfolio. We can also compute the time series of portfolio weights using this formula. The portfolio returns can be calculated in 2 ways. The standard way would be to use the values of the portfolio and repeat the operation that we have done for the prices of the assets. That would be the time series of portfolio returns. There's an alternative way of doing this, and that's multiplying the weights of the assets in the portfolio times the returns of the assets, and then taking the sum over the assets. Notice that this gives you the same time series of portfolio returns.